All right, so we're going to move on now to chemical bonding, which is, in my opinion, the most interesting and important part about chemistry, and really is what chemistry is, right? We want to study matter and predict how it's going to react. So atoms share or exchange electrons to form chemical bonds. And so naturally, one question you might want to ask yourself is, why do atoms bond, right? Why do they do this? Why do they transfer electrons to form molecules and compounds and whatnot? Well, if we think about it, we can ask ourselves another question. If we have this kind of little hill right here I've drawn, if we place a ball somewhere on this hill, what's going to happen to the ball? It's going to go down here, and eventually it's going to end up at the bottom of this hill. And then if we think about kind of the energy of this hill, it's always going to go towards the lowest point of energy. And that's the same thing that atoms do. The reason that they form bonds is because they're more stable that way. They're in a lower energy set. So for example, this picture right here shows the formation of a H2 bond. So we have a atom of hydrogen with its one valence electron, another atom of hydrogen with its one electron, and they are going to combine to form a chemical bond. And the energetics of this are that it releases a whole bunch of energy. It becomes more stable. So the energetics are negative 426 kilojoules. We'll learn about kilojoules and whatnot later. But again, the reason that they do this is so that they can get to a lower energy set, right? When they're far apart, they have a higher energy. And if you try to shove them really close together, it's a higher energy. So they form this chemical bond that's the kind of perfect low energy state. So the answer to our question of why do atoms bond, it's to achieve a more stable, and by more stable, we generally mean lower energy state. And so the chemical bond is a very complex topic, and there's many models for chemical bonding. Of course, you might ask yourself, why do we have so many models? Why don't we just use the best model that we have? Why don't we just explain exactly how it is? Well, the issue there is that the more accurate your model is, right, the more precise, the better it is, the more complex it is. And here I'm not talking about complex in terms of, oh, this is hard to understand. That is also true. But I'm talking about in terms of, the mathematics behind it. To kind of calculate and use some of these models, you need very powerful computers to even do relatively simple tasks. And so trying to use the most accurate model, a lot of times it's just not worth it. For most of our purposes, and most purposes in general, we don't need the most accurate model. So it's a bit of a trade-off, how much precision, how much accuracy do you need? And then you want to put in, you think about how much effort that requires, and you want to find that happy medium. So in terms of like the most accurate model for chemistry, the main one that we have is molecular orbital theory. Which we'll take a look at the end of this, but that's not the one we're going to mostly use. We're going to mostly use our Lewis diagrams and whatnot, and those still have amazing predictive power and are still quite accurate, especially for our purposes. So then the last thing we want to understand about chemical bonding is that the properties of the compounds that are formed can be completely different than their parts. So for example, on the left here in this jar, we have some sodium. It's a shiny metal. It's very malleable. You can squeeze it easily, all that kind of stuff. Then here we have chlorine gas, right? As you can see, it's a yellow gas. Both of these, if you were to try to ingest them, they would be very toxic. But when you combine the two, you form sodium chloride, which is table salt. It's a very hard substance if you think about how hard it is to crack a crystal of sodium chloride. And it's also perfectly fine for us to eat and is actually necessary for our life, right? So the products can be completely different than what they were made out of.